All right, this is Professor Pelton. This is part 3 of chapter 5, uh, section 3. Okay, so we're going to determine the polynomial for this graph of least degree. Because here's the thing, if I figure out the um, x-intercepts here, so the x-intercepts are clearly at -3, right? So x plus 3, if I solve that, will give me -3, correct? And the next one is 2. So if I do x minus, that's not an x, what happened there? If I do x minus 2 and I solve it, I'll get +2. And the last one is 5. Okay, so that is x minus 5. If I solve that, I will get 5, right? Because obviously if you do x minus 2 equals 0, you add 2, you get x equals 2. Hence the logic of why those are the factors. Then the question is how many times do they repeat? So we're saying least degree for a reason, okay? Because it could be many different, infinite number of things. So it goes through the graph at -3, so we're going to assume that's the first power, okay? It bounces off the graph at 2, so we're going to assume that's second power. And at 5, it goes through the graph, so we're going to say the first power, okay? There could be higher powers where it looks exactly the same as it passes through there, but we're assuming least degree. So maybe it could be 111th power. We don't really know. Okay. Um, and there's an A out front. So in order to solve this, we need one more coordinate. And you can pick any coordinate on the graph you want, but the easiest coordinate to pick is the y-intercept. Okay. Because there are infinite number of functions that pass through these three intercepts. We need one coordinate to orient it to be the correct function that passes through it, right? So we're assuming least degree. So 1 and 2 are the least degrees to pick. They either bounce off or go through the graph, okay? And we need one coordinate because there are an infinite number of graphs that go through these coordinates. So then we chose the y-intercept because that's the easiest one you can do. So if I plug this in, I get -2 equals a, 0 plus 3 to the first, 0 minus 2 to the second, and then 0 minus 5 to the first. So -2 equals a times 3 times 4 times -5. So we have -2a. Let's see, that'd be what, 60, right? 12 times, yep, 60. No, no, -60, sorry. Almost messed that up, right? So if I divide by -60, right, a is equal to 1/30th. Okay, and that makes sense because that gives me a positive a value and the graph goes up. So if I rewrite my function now, my function is 1/30th x plus 3, x minus 2 squared, and x minus 5. That's a bad square. Let me rewrite that. So essentially, that's my function. And I can verify it to myself within behavior. Because if I multiply that all out, right, I would get 1/30th x to the sixth power plus a bunch of other terms, right? And since it's a positive 1/30th, it goes up, and x to the sixth power is the same direction. Okay, so typically they would give us what the power is, and we can decide based on that, and we give a more accurate function. So let's assume that it's a 6-degree function for this particular graph. Okay, so f of x equals a times, so this one right here is -3, so x plus 3 is the factor that'll give us that 0. Since it bounces off in a quadratic manner, I'm going to assume that's second power. So the next one is x plus 1, because it bounces off at -1, but it doesn't bounce off, it passes through, but it passes through in a linear manner, so I'm going to say 1, which is odd. And the last one, x minus 4, okay, right there. So that passes through the graph, so it has to be odd, and it's passing through in a cubic manner. So I'm going to say 3. So 3, 2, and 1 give me 6. So that's a degree of 6. So I need one other point because there's an infinite number of graphs that go through these coordinates. I need one other point. So I can pick any point I want on the graph, but the y-intercept is the easiest one. So why not pick the easiest one, right? So that coordinate is 0, comma, -120, right? Because it goes by 40 if you count there, or 80 if you go every other, right? Okay, so I'm going to plug that in. So -120 is my y value, a, and 0 plus 3 squared, 0 plus 1 to the 1, and 0 minus 4 to the third. So that gives me negative 120 equals a times 9 times 1 times third power be negative 64, right? So let's see, negative 120 equals a, so 9 times 64, 576, but negative. So if I divide by negative 576, a equals 120 over 576, which is 5 over 24, and take out the common factor. Okay, so my actual function is 5 over 24, x plus 3 squared, x plus 1, and then x minus 4 to the third power. Make a better square than that. I don't know what keeps happening there. Okay, you could spend the time to multiply it all out to general form. It's not really necessary. Essentially, if you multiply it all out, you'd get f of x equals what? 5/24 x to the sixth power plus a bunch of terms afterwards, right? Because you have 2, 1, and 3 for sixth power, which makes sense for this graph because the end behavior is both up. So a positive 5/24 and x to the sixth power would make sense to this. Okay, so on the back, there's some student problems. Try them for yourself. Pause the video. Okay, so next one we're going to assume is 7th degree, right? So f of x equals a. We're at a negative 5, right? So x plus 5. And we'll say third power because it looks like it goes through the graph, which is odd, and in a cubic manner, so we'll say 3. And then this one goes through at negative 1, so x plus 1. It bounces off the graph in a quadratic manner, so I'm going to go with 2. And then x minus 3, it's bouncing off at 3, and it's bouncing off, so it has to be even. We'll go second power. So we need a coordinate now. I can pick any coordinate I want, but again, the y-intercept is the easiest one to do. It's less work with the 0. So 10 equals a, 0 plus 5 to the third, 0 plus 1 squared, and 0 minus 3 to the squared. So 10 equals a times 125 times 1 times 9, because you squared 3, right? So 10 equals a times 1,125. So a equals 10 over 1,125. That's common factor of 5, right? So it's 2 over 225. So my function is actually 2 over 225, x plus 5 to the third, x plus 1 to the second, and x minus 3 to the second. So there's my function. If you multiply it all out, what would you get? You get f of x equals 2 over 225 x to the, let's see, 4, 5, 6, 7, and there'd be other terms afterwards, but they don't really matter, right? And if you think about the end behavior of x to the 7th power, it's two different directions, right? But the 2 over 225 makes no difference because it's positive, right? So multiplying by a positive doesn't change anything. So in the positive direction, you go positive. In the negative direction, you go negative. So that actually makes valid sense. Okay, let's try the next one. Okay, so we're assuming that it is a 6-degree polynomial. So f of x equals a, and the first one is a negative 1. So x plus 1, we'll say to the second power since it's bouncing off the x-axis. The next one is 2. So x minus 2 will give us 2. And we'll say third power since it's passing through. And it kind of looks like a cubic manner. And the last one is 4. So x minus 4 will give me 4. And it's passing through in a linear manner, so I'm going to say 1. And that adds up to 6, which is what we want anyways. So an easy coordinate to pick would be our intercept, which is 0, negative 4. So negative 4 is equal to a. 0 plus 1 squared. 0 minus 2 to the third, and 0 minus 4 to the 1. So negative 4 equals a times 1 times negative 8 times negative 4. So negative 4 equals a times 32. So if I divide by 32, a equals negative 4 over 32, which is of course negative 1/8. So the function is negative 1/8, x plus 1 squared, x minus 2 to the third, and whoops, x minus 4 to the 1. All right, so that's in factored form, or what's called intercept form. If you multiply it all out to general form, which is not necessary unless it asks for it, you get negative 1/8 x to the 6th, right? Because you have 2 here, 3 here, and 1 here for 6 x's, and the negative 1/8, so plus some other terms which are relevant. If you think about the end behavior of this, right, the 6th power makes it go in the same direction, times the negative 1/8 afterwards means both directions go down. Okay, that is the end of part 3.